Hi everyone, welcome to AmbiTalk, the AIR sessions. I'm Ronan Cooney, and this series of interviews I'm going to be talking to leading experts in academia and industry about air and the importance of the air we breathe, the impact on us of the everyday environments that we occupy, and how these environments really are changing and will set to change in the years to come post COVID-19. So at the moment, globally, where over 90% of our lives, of our entire lives, is spent indoors, be that in our homes, vehicles, workspaces, things like that. So really sort of interesting to see that, there's little, if little knowledge really known by most people of that environment and its importance really on our long-term health. So I'm delighted to have Gavin Phillips, the acting head of mathematical and physical sciences from the University of Chester today to discuss this in a bit more depth. So hello, Gavin.
Hi, Ronan. How are you?
Good, thanks. And thanks a million now for taking out the time. I know since COVID's kicked in, and we were discussing earlier that it's kept you busy and on your feet with plenty of different projects. So thanks for doing this for us. So I suppose, Gavin, we might just kick it off. You might just be able to tell everyone a bit about your background and how you've ended up. I know you've taken a few twists and turns along your career to date. How you've ended up where you are at the moment.
I originally studied chemistry back in the 90s at Loughborough, and I did a PhD at University of Leicester in atmospheric chemistry, so chemistry of the air. And I focused on the chemistry at about 10 kilometers in altitude and spent a lot of time analyzing field data from aircraft measurements. I worked for a number of years for the UK government for a research institute called the Centre for Ecology and Hydrology, where I was an atmospheric chemist. And we used to do air science, so physics and chemistry of air all around the world. And we used to look at the impact of cities, of different types of ecosystems and land use, like rainforest, oil palm plantations, other types of farming, livestock. And then I moved to Germany for 3 years and was a research fellow at the Max Planck Institute for Chemistry, doing very, very similar thing, the chemistry of the air and the air pollution, so outside. And in 2014, I moved to University of Chester, and I took up a position as senior lecturer in natural sciences, and I'm still there, kind of in that position today. And I noticed that there was a area that was fallow, and that was the science of the indoor environment in terms of my area, which was chemistry. So now I run a number of grants on using engineering and to manage healthy indoor environments and understanding how we impact our own health by our own activities indoors.
Great. And I see you even got to spend some time in Alaska at one stage. Is that right?
I did. Yeah, I forgot. Yeah, I did a postdoc. After I graduated my PhD, I did a postdoc. So one of those short-term academic jobs you do. But I was in University of Alaska Fairbanks for a couple of years, and I was studying the photochemistry of snow. So it turns out the snow does a lot of chemistry, so which I didn't know at the time either. But I did after I'd done that job.
So you've gotten around over the years anyway. It's great. Yeah. And maybe just give us a bit of a rundown on some of the projects that you're running currently in the university.
So I'm quite active actually, and we do various projects, and they're funded by different funders. So we work with industry like yourselves and other companies on issues to do with indoor environments and air quality and air chemistry in general. So we've got projects involving sensing systems and using various types of clever data science to understand how sensors can help us manage indoor. We have internally funded projects. One of the projects we've got going, it's kind of going at the moment. We've been looking at safety under the pandemic conditions. So how many people can you have in an indoor space for particular ventilation rates? So using monitoring, using carbon dioxide monitoring, using other measurements of indoor sort of traces of air quality, and understanding and modeling how safe you can be and maybe predicting what safety might look like in the future, and maybe trying to understand how much money you could save by improving the health of indoor spaces. We've got some government money to study how indoor activities in homes, so cooking and cleaning in your own home, how that impacts your air quality in the house. So when you cook, especially, for example, when you fry, you emit a lot of particulate matter, and that particulate matter is breathed in by the cook or anyone else in the area. But if you happen to breathe those particles before they're ventilated out of the room. So there's interaction between building physics, the design of spaces, the activity of occupants, and the activities you do. So, whether you're frying, you're cooking bread, you're using gas hobs, which emits nitrogen dioxide instead of using, say, an inductive hob, so a lot of these different issues we're studying.
Very good, very good. And you sort of mentioned there briefly, but is that funding, are you seeing it coming from industry or from like government sort of level, or a bit of both, or which is really sort of driving it, do you feel, at the moment?
I think it's kind of a bit of both. So we certainly see more interest from industry, asking us to test equipment and to calibrate sensors. So there seems to be a lot of people who I haven't heard of going into the market of measuring indoor air quality, but there's also interest from the building the building asset management world, to understand what systems are good, because these people have come out of the closet and asked, buy our system, it's great, and I'm getting asked, which is the, are these people talking sense or are they not? And a lot of people are asking that. And generally, you don't get government funding unless reviewers think it's worth doing nowadays. And so the fact that we've got UK Research Council funding to study indoor activities and the impacts on air means that it's far more salient, now, and it's realized that there's a lot of impact that could be had from understanding far more about our indoor environments and the chemistry of that, as well as the great work that's gone on in the past in engineering about indoor air quality.
And do you feel, since sort of COVID-19 has sort of become a pandemic, really, that sort of increased, so that interest has increased externally, and you're seeing more and more of these projects sort of coming online, or about the indoor?
Yeah, I mean, I couldn't give you a quantitative answer, but I could say my feeling is yes, definitely. I mean, one of the things I did really early on in the pandemic is when I go to a coffee shop all the time, and it's in an old, nice old sort of building, but it doesn't have a ventilation system, and so I know the owner, and we did some calculations, and we worked out the size of air cleaners that possibly that she should install. And so even everyday people are thinking, we didn't realize we can manage maybe COVID risk by managing ventilation and understanding the balance between clean air and healthiness, and yeah, it definitely is far more salient. And we got money internally in university to address COVID issues, and my group was in a position to help because we knew a bit about the subject. So we were just sat there, and we saw an opportunity, and they gave us the money. So we wouldn't have got that money normally to do monitoring of indoor spaces if it hadn't been for the pandemic. And there's certainly a lot more about ventilation on the news nowadays. And so I definitely think it's starting to be more of a more commonly recognized as an issue.
Yeah, it's funny that I suppose a lot of the time academic work doesn't get front page news or the coverage maybe that it should, and I guess that's one of the things that we're seeing with COVID, that really this academic work is so important, and the results that it drives, that really builds everything, can build from there. It's given that base in academic work. So it's great to see that importance being shone on the work that you're doing, I think, at the moment, which is brilliant. And I guess then just around the campus, and student health and productivity and cognitive function and all this sort of thing. I don't know how you've seen that importance of the change, or the work that you've seen to date on that, and the impact that that can have.
So it's an area I'm really interested in, and certainly, pardon me, certainly, it's been a funny interaction because if we go to university managers, people, and say to them, oh well, you can actually, productivity. So I would call it learning gain. Like improving. The students are all half asleep because the carbon dioxide's at 5,000 ppm. And they're not learning. And there have been a number of studies that have suggested that poor ventilation, or possibly even CO2 itself, I don't know, but CO2 is a proxy for poor ventilation, and these other substances that are emitted indoors, can affect your ability to work, and whether that's measured as productivity or whether someone's learned something effective. So obviously, as a learning organization, so as a university, we're really interested in, first of all, the productivity of all the staff, but we're really interested in, if the students are all asleep in class. And so the fact that we've done this work because of COVID on, we've surveyed rooms on what the ventilation rates are, and it does give us an evidence base to start to have a conversation with senior managers, because previously, if we said, oh, can we have $5,000 to go and measure CO2 in loads of rooms, they would tell us to go away. But we've had a reason to do it now, and it's been a really important reason. And so we've gathered evidence, and we're able to say to them, look, this space is good, and this space is not so good. And maybe even clever management of space, to enable decision making. So it's not just about, oh, everything's terrible, make it better. It's about having knowledge from systems like IoT, using IoT, using clever ways of understanding space, and using, like you said, that sort of underlying evidence base that poor air is not very good for you. It's a matter of persuading these senior people that actually, invest in a little bit of money will have these huge benefits, these huge gains in student performance, maybe for relatively small amount of investment in understanding space.
And I think we've sort of seen that really as well in some of the work and trials that we've done with educational spaces as well, which, schools have been one of the few areas that have been pretty much fully occupied during the pandemic, which obviously they're not at the moment, which is another controversial thing that maybe we won't get into. But monitoring those is really the realistic situation of what offices are going to get into. It's whether you're students or you're in a university or an office, it's the same sort of impact that you're going to have through every industry, through every sort of company and space that's been there. So that's been very interesting to see. And how do you feel then about, I know data and GDPR and all these sort of things then come, but with sort of open source data then and giving it back to the students so that they can see exactly what's going on their campus or in their rooms or whatever, and they're, I guess, engaging a bit more with people like yourselves, and they can see what's going on and feed that back to you. Do you think that's an important part to it, or?
I think it's really intrinsic. I think it's really important. So I think at my university we have our senior management are really keen on the students as citizens. So owning their surroundings, really. So interacting properly instead of just being passive receivers of knowledge or wisdom or whatever. But I certainly find they learn better if you give them realistic information and problems. So if you teach engineers and scientists, you teach those students, even any student, it doesn't have to be an engineer or a science student, but about data, about what to believe, what you can learn from data, the fact it's not infallible, and that that you need knowledge, that you need ethics, you need data management skills, you need to be able to program, you need to be able to visualize, you need a bit of creativity. It's all really good, and I do feel strongly that if you show students how things are relevant, they A, learn better, but B, they get engaged and they want to change things and they want to suggest things. So I certainly think that what I do, I try and get students involved. It really benefits it, because sometimes I learn a lot from them sometimes, like different perspectives. I might not learn technologically from them, but I learn about how to use things, or maybe what other people, I'm assuming a lot of things and they're not. And so everyone learns, everyone gains from it. So I think that as long as you manage the data and privacy and sort of the various sensitive sensitivities around commerciality and commercialization, and universities being a bit funny about those sort of things as well. I think you can certainly gain a lot from analyzing these big data sets. And I can imagine if you had a lot of schools involved in trials, and you could learn a lot from it, and students would learn a lot as well.
And I suppose another thing that we've sort of seen as well is like if you can't define the problem to begin with, how can you tackle it? So like you're saying, the data side is key, but again, like you're saying, getting that feedback from students on their concerns, and it is a very worrying time for some people, and the risks that they're seeing every day of coming into university or school, and to know that it's a safe place for them to go. So having that talking with the students and that interaction is definitely interesting and key, I think. And then I suppose just really to end on it, really, it's just, how do you see yourself, or what do you think that the changes might be coming because of COVID, really relating to indoor air quality specifically, and how it's really changed the world? Maybe there's no going back in certain areas, and what do you think that impact is going to be?
Well, I think a number of things. I think back to what I said before, is that COVID's enabled a step change of investment in certain areas. So I know this is not particularly relevant, but it's kind of relevant. But we've invested a lot of money in online learning. So there's a lot of learning that does not now need to take place in person, whether there's a pandemic or not, because we all know it's fine. Like it's great. You were busy. You had to take the kids somewhere, and then you were waiting somewhere. You could get on your phone and join the class. You didn't have to go. It's a lot more flexible, and as long as it's done well, it's fine. But that means space management has changed. Yeah, and so we've affected space usage. So maybe in a university, especially, or maybe even in offices as well. Although I talked to one of my brothers who works in a big company that has lots of offices, and they seem to be really conservative. They like, as soon as they want to go back, they just did everything the same again. And so, but in the university, I think things might change. The other thing it's done is, like I said earlier, it's given me money for a particular reason. But like you said, we've now realized we've got evidence of another issue, which we knew about, but then no one would listen to us because we were like, oh, well, that's your hobby horse, so we measure the indoor air quality, or we look at ventilation rates, and we understand them. We've got hard data, and we can show senior managers and organizations, and if we're clever enough with the econometrics, if we can be persuasive and say, this is euros or pounds you're wasting here, and for your huge return on investment, it's just persuading these large asset owners or senior managers in university that really it's worth their time when they've got a lot of other things on their mind, like keeping the students safe, keeping them happy, keeping the staff unstressed, when everybody's stressed. And so it's finding a bit of space in all that noise to make this argument at the moment. So whilst COVID's provided like an advantage, it's also provided a challenge, because there's so much going on. Yeah. People are like, indoor air, it sounds a bit odd. I don't know. So the building regulations in the UK are out in consultation, and in Part F, so the ventilation part for commercial buildings, it's been suggested that ventilation be monitored in spaces, in some office spaces, and using, for example, carbon dioxide monitoring. So it is getting in government regs. So as soon as it gets in government regs, it becomes salient because it's pounds. So, I think indoor air and the monitoring of indoor air will become far more normal. And we will hit the problem that, some people will do it well and some people won't do it well, and it's just, you know, having the skills and the knowledge to understand when it's just been done to hit the building regs, or it's actually going to give you a monetary advantage as well.
Yeah, keeping that quality high, I guess.
Keeping the quality high and really providing an advantage instead of just doing it for doing it safe. Because you know, everyone knows, you know, they probably live in a house that was built to some sort of standard of building regulations, but those were correct when the house was built. You know, when your extractor fan stops functioning or starts making a funny rattling noise and you just don't use it, it's not doing anything anymore. And so it hopefully real-time monitoring of the state of operational sort of status of buildings will mean that these sorts of things, you know, in domestic environments, yeah, that's a different kettle of fish. But in work environments, maybe it'll be far more salient that building systems are not operating correctly, or they could be operating better, and they could be providing productivity gains maybe, and certainly better spaces to work.
Yeah, definitely. Okay, Gavin, well, thanks for your time. Some very interesting points there, and I really appreciate the input that you've had, and like I said, taking the time to talk to me today. So much appreciate that, and yeah, talk to you soon.
Thanks, Ryan. Take care.
Yeah, cheers.